Hey, MJ here. I'm going to try to work on some circumference. So, we know circumference, the formula, or we learn in class the formula. Circumference of a circle is pi times diameter. Okay, so that's like the starting point. Okay, when we get to our test, it's going to be important that you can find the circumference or find something from the circumference, right? Like find the diameter if I give the circumference, or find the circumference if I give you the diameter or radius, et cetera, et cetera, et cetera. Okay, but it's also going to be important that you can prove to me sort of why that works and also why pi is what it is, right? Because like pi is weird. It's literally 3.14159. Like it just keeps going on and on and on forever, and it never repeats. So it's like the worst thing you could do for like kids that are 12 or 13 is be like, hey, we're going to use this number a whole lot. It's called pi, first of all, and it's like, what the heck? Why does it have this weird name? And like, second of all, it doesn't make any sense, and it's super weird, and it never ends, and it never repeats, and it has an infinite number of decimal points. Let's work, right? Like that's terrible. Like if pi was 10 or 5 or 2, like it would, or even just 3, it would be so easy to work with. But instead, it's this super weird sort of. It seems like random, right? It seems like the worst thing possible. Why would you pick this? And the point I want to make clear to you is that nobody picked it. Okay, it's not really a number at all. It's in fact it's a ratio. Okay, and it's a ratio of the diameter of any circle to the circumference of that circle. So it doesn't matter if it's a big circle, small circle, a minuscule circle. As long as it's a perfect circle, its diameter will be related to the circumference by pi. Okay, if you take 3 diameters, you don't quite get the circumference. You need that extra little bit. Okay. So that's what I hope to model here because you need to model it on your test. So let's build a circle in GeoGebra and let's see if I can get it to go right. We might as well get a whole number as our diameter. So there's my circle, okay? If I want to show the diameter, as we know, the diameter goes from circumference edge to circumference edge through the middle, through the origin, okay? Now let's check our measurement tools. Let's see if I made that exactly, what is that, 6? 8, okay. Beautiful. So now we've got a nice, I can't move that 8, whatever. Okay, so we got a circle with a diameter of 8. Okay, so the first thing I would think about if I'm doing this question to test is like, what is the circumference going to be like? Like, what's it going to be about? Okay, so before I do the math, I just think, okay, well, if the diameter is 8, and I know that it takes a little more than 3 diameters to wrap around the circumference, then it's going to be like 24 and a bit. Okay, it's going to be 24 and some more. Okay. We'll find out how much more in a second, but it needs to be more than 24. Okay. So if I do all the work, I do all the math and I get my calculator and everything, and I get 22, then I've done something wrong. Okay. If I get 10, I've done something wrong. And certainly if I get a number less than 8, I've done something wrong. Just look at it. If that's 8, I can see that it's going to be, more than 3 eighths around. So it's got to be more than 24. Okay. Now, the proof as to why that works. So the model that you're going to want to show on your test, I'm going to bring my my drawing tools back. And I know my drawing's terrible, but hey, what are you going to do? So that's the diameter, right? Going through there. Well, that's actually pretty good for me. That's a pretty straight line. And that's a value of 8 units, 8 centimeters, 8 feet, whatever, okay? If I was to take that diameter and make it floppy, right? Make it like out of string, let's say, instead of like a ruler or measuring tape, then I could wrap that diameter, oh my God, sorry. I could wrap that diameter around and like until I get to about 8. That looks like it's about 8, okay? So that now is 1 diameter. And obviously 1 diameter did not get me around the whole circle, okay? So I start wrapping a second diameter around the circle. And that looks pretty good. So now I have 2 diameters wrapped around the circle. So that would be 1, 8, right? Because 8's my diameter. So 1, 8, a second 8. So far I'm at like 16, okay? Or not like, I'm at 16 if my measurements were perfect, which obviously they're not. Okay, now we bring in a third diameter, and I get to like there-ish, maybe a little further, but whatever. Let's just say I'm right on. So now that's 3 diameters, okay? So that'd be 8, 16, 24, okay? But I've got this extra space, right? I clearly can't fit like a fourth diameter is not going to fit in there. It's too big. The space is too small, okay? So that extra space is important, and we don't know what it is. That's supposed to be a question mark, by the way. Okay, how much is it? Well, if we had done this properly and carefully measured and used good rulers and measuring tapes and whatever, we would discover that that is not a full diameter, but is 14% of a diameter, okay? Another way of looking at that is as a decimal, 0 and 14 hundredths, okay? And there's more numbers after that. But that's how much it is, okay? Not 20% of a diameter, not 10%, not 15, but pretty close. 14% of a diameter would fit in there, okay? So that's why pi is 3.14, and there's more numbers after, because it doesn't quite fit even that. It's 1592, blah, blah, blah. The numbers go on forever. As we talked about in class, they've got it up to 31 trillion digits long, okay? Never ends. But for us and for almost everybody, 3.14 is good enough, okay? So that's my proof. That's why pi is 3.14. It's not just made up. A bunch of old guys with gray beards didn't get together and be like, let's come up with a number to use for pi, right? It has to be that number because it's not really a number. It's a ratio. It's how many diameters wrap around a circle, 3.14, okay? So that would be the model that proves it. And that's how we can find our circumference based on the diameter. So if we know that circumference equals pi times diameter, okay, and we don't just know that, we just proved it, right? The circumference is how many diameters? Not 1, not 2, not 3, but 3 and a bit. 3.14 times the diameter, right? So since we know, in this case, the diameter is 8, then we would just say circumference equals pi times 8. And then we just bust out our calculator. I'll do it on my watch really quick. What is 3.14 times 8? 25 and 12 100ths. Okay, and that would be just units, centimeters, meters, miles, whatever it is. It's not squared because we're looking at a straight line, right? So 25.12, 25 and 12 100ths units long, okay? And that's what we said early on. We said it's going to be about 8 times 3, so 24, and a little bit more. How much more? It ended up being 1.12, which makes sense because, you know, it's 8 of those, okay? So that would be my answer. That would be my model. The answer makes sense. I'd always just quickly check. Does that make sense, right? If this is 8, should this be about 25? Yeah, that checks out because it's 3 and a bit more, okay? So that is circumference of a circle explained and why pi is what it is. There's some other models we looked at in class about putting, you know, starting with a triangle around the circle and then trying to get more and more sides to your shape. And the more sides you add to your shape around the circle, the more circly it gets. And that gets it closer to 3.14 as well. We saw that in class on, I think, Desmos, right? But there's, I think, the easiest one to sort of draw on a test, why the formula works, okay? Hopefully you found that useful. And if not, I don't know. I don't get paid for these videos anyway, so whatever. Peace.